yeah, so the first thing I wanted to do is to just try the source code and see how far I can get. Okay, I've cheated a little bit. I went into the issues here. So I normally like to look at the GitHub issues. So I had a look for some of the issues just to see if people were complaining that it doesn't work. And I found that actually someone actually created a Google Colab somewhere. So so hopefully this Google Colab works. Oh, okay, no, I think that I'm pretty sure that someone added one. This one doesn't look like. I'm pretty sure I found a Google Colab. You see. So I think that someone actually managed to do one. Okay, there's a Google Colab kindly created by Nevrix on GitHub. I haven't had a look at this, so I have no idea if this works. Let's see. Okay, so the idea is I want to see how this works without doing while doing as less setup as possible. So let's see what we need to do. Okay. So first thing, of course, we need to download the EG3D source code. Yeah, and okay, that should be fairly enough. So Nvidia semi, let's see what kind of GPU we are dealing with. We are looking at excuse me. All right, sorry. Okay, so Nvidia SMI. So Tesla T4, I think it has 16. GB of VRAM. I think you can't see that here for some reason. Somewhere. Okay. So we've gone the project, and here there is a URL to download the model, the pico file. So it's a pico is like a binary basically is a binary representation in file format of a model that was frozen. So we're downloading the pico file. Let's see what happens. Okay, that shouldn't be too big, hopefully. It should be very quick. Okay, so we need to install this. So this is I mean the model itself runs in PyTorch from what I figured out before. So PyTorch 3D probably, we'll see. Oh, Nvidia Kowin, because that's the Nvidia library that they've created for 3D deep learning. Okay, and this is a Ninja build. I'm not sure what Ninja build is for. We can find out. What's Ninja build? Not ninjas, hopefully. What is this? Ninja. Oh, a Ninja build system. Oh, I didn't know about this. Okay, it's a Ninja build system. Let's continue. And then we have a library scikit video. And we have this library. I don't even know what this is. Oh, pips. It's a very strange name. Okay, so we have perceptual similarity metric and dataset. Okay, this looks like Okay, maybe it's a way to evaluate visual quality or something like that, right? Looks like a library from another paper, which is okay. So we are downloading that. Did we run this? No. Okay, then TriMesh. I've dealt with TriMesh very recently for another paper. This one was PIFU. TriMesh is a popular library, and you have to be careful with this one because TriMesh has some ray tracing calculation methods that if you don't install, is it, I think Priembry, if you don't install it, Priembry is a very slow method that called the ray tracing takes forever in large meshes. But if you install this library from Intel called Priembry, let me just show you the name. Anyway, I'm coming out with a new video explaining this. I probably mispronounced the name, sorry. I'm not sure if I got it right. TriMesh. Priembry. Oh yeah, Priembry. Okay, got it. So Embry is the library from Intel. So this is the very highly optimized. So it's not even using a GPU. It's just very mathematical. So this library is very efficient in doing ray tracing calculations using a CPU. So it's quite. So it's used by TriMesh. So TriMesh is a popular project from, and it's using 3D deep learning. It's also used by Nvidia Kowloon, by the way. So this is an important library to know about. Triangle, okay, right. For triangular meshes, as the name kind of highlights. Okay, so have we installed TriMesh? Okay. The thing is, I'm not seeing a Priembry being installed, so I assume that whatever ray tracing calculations we have to do here, they're going to be fairly simple. Otherwise, okay, so now we are installing. Okay, what are we doing here? We are appending this folder path so that we can basically import. And we are setting some debug here. You're looking forward to this one. Okay. So I'm not sure what this one is doing actually. It's getting the GPU and then opening the model. Okay. And now, so this is the bit which so generate random image. So basically we are generating a random image. Because of that, so it's going to take a bit of time, but we can scroll down to see. I think I have some images. I don't have face images like this one, maybe. Let me just check. Yeah, in the meantime, while this is running, I'm just going to check my library of photos privately, just in case, just to find if I have some kind of a face photo that I can use. I should have some. So let's see what to put. So let me find one. Can you hear me okay? I hope my sound is working, right? Yeah. I think I can see what is. Raspberry Pi photos. Okay, I found some, yeah. I have some funny. I don't know if this one is okay. Let's see. I have more. If this is not, I'm not sure. If this doesn't work, then I will find something else. I'll keep it here on the side. Actually, I'll keep it here. These are pictures for thumbnails, so I have to make some different poses. Okay, right, so we have here an example. Okay, so what did this do? So is this an image of a random person, I wonder? I think it is. That's probably what I meant by random. So it's using probably the Nvidia style gun, yeah? Okay, so I think that's what it's doing. Okay, so let's see. Invert your own image. I don't know if this is going to okay, so there's a lot of parameters here. How can I add my own image? Okay, do I have to upload here something? Choose. Okay. So I can actually add something here. So I have to run this. And then I'll just pick a photo. What's this? So I need to go into the path, into the right place. So pictures, Photoshop, thumbnails. Okay, I found it. I probably should use a normal photo if I can. Let's see. Probably not very, I need to probably crop it, maybe just to make it a bit similar to the image here. But anyway, this is probably not very important. I probably should just use the best image at hand and then try to do the conversion to 3D. So this is a random person. I need to look at the code a bit more in detail later. This looks more. This looks like the style gun model that just generates images. Oh no, it kind of. This is a. I think it has to be a square, so that's why my image is not a square. So I need to do some cropping. Here comes Photoshop. I've just learned how to crop something in Photoshop, right? So my Photoshop skills are getting better and better. Yeah, I have to learn how to do thumbnails, that's why. I think actually you can do this easily without Photoshop, right? Just do cropping, edit image. Okay. This is not, it looks like a square already, right? Square, let's see. Custom square. Oh, I see. This is a square. But this photo is probably not the best because I'm hiding my face, and I don't know if the model has been trained like that. So I'm going to try and pick another photo. So this one is probably not going to work very well. Okay, so something, do I have anything? Okay, this one looks like normal, right? Okay, let's try the square. Where did I do that? Yeah, here, somewhere here. I can even add 3D effects, that's quite cool. The edit was somewhere. Okay, I found it. So I just have to change the aspect ratio to square. So simple enough. What I want to do, actually, I want to try and keep as much as possible this. So I'm going to make my face a little bit bigger. No. What happened there? I need to move that. There's no drag and drop for some reason. Yeah, perfect, right? So this is almost like, okay, it's as close as I can get to the style gun photo. Style gun. Okay, right, and now I can just upload this. So let's run this again. Hi, thank you. Thank you for wishing me good luck. I think I need it. I'm running this for the first time and I wonder whether I'm going to get any results or not. But it seems like whoever wrote this notebook, well done, seems to be working so far. Okay, so I have a photo here. So let's see what we can do with this. I'm going to use, to be honest, all of these numbers, they're kind of a little bit abstract to me right now. Because I don't know what were the settings in the camera. So I'm just going to leave the defaults for now, and then because I really have no idea, to be honest. This is just experimentation. So everything I'm going to leave as default. Assume that this is the best they can do. So let's try. And see how... The last time I tried to do a 3D model, it turned out to be a monster. So let's see. Do I have to make sure the path has... Oh. I wonder if I have to match the file name. Oh. What's happening here? So I have... What happened there? This is... Yeah, I'm not 100% sure what this... Okay, I know this one, it's me. But then this one, okay, I understand there might be a style gun. And then... Wow, it's actually changing? Wow, yeah, it's looking cool. Yeah, so wow, what? Okay, and it seems to be, yeah, I'm not 100% sure of what this is doing, to be honest. But you know what, let's just let it finish. So it's doing some training, I can see. So we can see the loss, this number perceptual. That's probably based on using that library that we saw, the what was it called, the LPIPS library. So this is probably why they use it. They have a score here. And then MSC, I'm not sure what the MSC is for. We can always try and go back to the paper and see what it actually means, all of this. But this is probably going to take a while, right? It's 1%. If it's going to be that long, we might have to get 1%. So okay, so yeah, I'm not sure how long this will take, but you know, just let it go. This 1% is going to go a bit fast. It might take a few hours. Right, this is the last bit, and I think this is what they wanted to show. And you can see, right, from the photo, it's a front-facing photo, right? And then it goes, you can actually see a 3D, it's moving, right, in 3D space. And that's what it means. And they probably are fitting. So this is the original image, like the one I have here. And these are the, so it's currently fitting those images to me. Now I can create a cool video if I wait for, oh, there's another one. Ah. So how many more hours for this? Oh, can't even see how long it takes now. It's disappearing. So there's no progress bar anymore, for whatever reason. I just have to keep, I just have to be a bit patient. Oh, we get a mesh at the end, which is quite cool. So, but then, okay, I'm going to go into GitHub just to have a look at the comments to see what people said about this. So this is what I've done. Okay, anyway, so this notebook will take some time to run, and while it's doing, oh wait, What happened there? I think it's finished. Yes, finished. But I don't know if... Okay, let's see. I'll run this and see what happens. It's still running. Oh. Seems like I got kicked out from Google Collab. I don't know if it's because they needed the GPU. I wonder. I forgot even to check the runtime version there. It's a GPU. Connecting. So I lost my connection to the GPU. Yeah, once a window works. Let's connect and do it. So I don't have much luck today because connect to a hosted runtime. Okay, maybe I will just refresh the page and see what happens. I got disconnected. Oh, okay, so they're saying if this crashes, we should reduce the resolution. Early exit. Okay, it doesn't always go to the 100%. So maybe I can download this and see if this can actually run on my environment, right? I wasn't planning to try and run this on my environment, but I might as well try it since I have no option. I have an RTX 3070. I'm not sure whether it's going to take this. Let's see. It might work. An RTX 3070, as long as it's not doing anything too heavy, it should be okay. So I'm going to create a new environment. So go to environments, create. I'm going to call this Nvidia EG3D. Oh, I need to check now I need to actually pay attention to the version of, I need to know what version of Python they use. So let's see. Oh, it's connected. Oh, it is connecting again. Not sure whether it's actually. No, it's I shouldn't really rely on that. So let's see on the instructions here what is the requirements for the installation. So let's see. Okay, requirements: 1 to 8 high-end Nvidia GPUs. Okay, so that's not looking too encouraging, but 64-bit Python 3.8, okay, 5.8 is good. Included toolkit 11 6.3 or later. Okay, that's no problem. They have a separate CUDA toolkit installation. Okay. So Python libraries, C environment for exact library dependencies. Okay. So we can actually try and just follow this and see if... Okay, let's just... I'm just going to follow the instructions here. So I'm going to clone this. And I'm going to open... I'm going to use Ubuntu, I think. Do I want to use Ubuntu? Because if I use Ubuntu, I can use also the Nvidia. Should I use the Docker container for this? Because it might save me a lot of time actually. But then the instructions here are not for Docker containers, and I will end up having to figure out how to set this up. So I'm going to try and just go with the standard Anaconda. I'm going to use Anaconda, Miniconda. Okay. So just git bash at least, just to give me the comforts of the Linux shell. So let's go into cd docker to YouTube. I'm going to create a new one. Edit EG3D. Right, and here I can just do a git clone of the project. And you know, I'm not 100% sure whether it really needs like the very high-end GPU. And I don't know if it's going to work because I'm actually using my GPU for recording, for running Nvidia broadcast, and I'm not too confident that this is going to work, but I'll try and see at least how far I can get. PyTorch is actually better, I think, in terms of not being too greedy with the GPU memory. If you try to use TensorFlow, it will try, unless you stop it from doing that, it will just grab all this GPU memory available. Okay, right, so let's do the conda active. So conda env create. Okay, paste. Yeah, so it created a new, oh, what's the environment file? Okay, there's an environment file here in the main. So main environment. I thought there was one. No environmental YAML. Oh, so with the YAML with the one without an A. Okay, so I found it. Huh? It's just I was just missing an A. Oh, it's because it's inside another directory called EG3D. Don't tell me that. That's like 3 directories now. Okay, so this hopefully will make it really easy for me to install everything is needed. I don't even have to think about it, which you know, once in a while, it's nice to have. Okay, what happened there? Okay, can't activate free. Okay, so I need to do the Windows way. And it has to be... Okay. Could not find conda environment. I thought I created it just now. Maybe I didn't run this properly. Conda data bat. It has to be the Windows way. All right, so we have resolve package not found. Okay, why does it need? They mentioned CUDA 11.3, right? But it's looking for 11.1. So we have here the packages. So we have the, sorry, CUDA should be somewhere here. CUDA toolkit. So they mentioned something about a special CUDA. Okay, let me just check this. So CUDA troubleshooting. Okay, so CUDA toolkit 11.1. I'm going to go back to that notebook. It might be that he already solved this issue, right? May as well follow some of the steps just to save myself time. What did he do for Ninja build? Okay, install this library, lpips, tree mesh. Okay. Oh, this is my, wow. It looks a bit similar to me then. That's a bit scary, right? I think they've fitted his face to me. I'm looking into the paper from Nvidia EG3D. And I was trying this Google Colab notebook just as a quick way to try this model, which is supposed to take a 2D photo and convert it to 3D, right? And you can see it's a bit scary. It's trying to generate my face. It looks a little bit, I think I'm better looking actually. Anyway, yeah, it looks a bit similar in terms of, it started with a very like completely different person, and now it's looking more and more similar to me. And that's a bit scary. And then at some point I will be able to generate this type of video and then create a mesh, and hopefully I will be able to see myself in Blender as well. That would be really cool. So this is actually not too bad. Nerf yet. I haven't looked at Nerf yet. But I think this is actually a paper that's is also inspired by Nerf. Yeah. I'll probably look into that on another session. Okay, so while this is running, it seems to be running for a long time. I'm going to continue trying to set up my environment. All right, so I was trying to see where is this CUDA? There's CUDA 11.3 mentioned here, but then also they mentioned somewhere else in the troubleshooting, they mentioned CUDA Toolkit 11.1. So I'm a bit confused, right? So maybe 11.3 is for PyTorch, and then 11.1 is for the extra libraries they need. But it's not installing because it's saying not found. Resolve package not found. Let me go to the issues and see what people say, because normally in the GitHub issues, that's how you solve your problems. So issues. I normally like to see any issues, so because it might be already resolved and they would have closed this. Try that one. Just CUDA Toolkit. Surely this will have been one of the... Oh, they don't have any issues actually. Oh, they do. Okay, so this one. So resolve package not found. Filters. Okay. So I'm trying to... So the question is, are you trying to export environment path? What I'm trying to do, I'm trying to create my own environment locally, so I can run Nvidia EG3D. And I'm having an issue here because this package is saying it's not found. Okay. And I'm not sure why, because this should just work according to the instructions, right? Normally that's not the case, but this is what it's telling me to do. So I'm following everything, I think. So this is the environment.yaml. Even this link is not working. So they've changed things around a little bit. Now they've put it inside. Oh, am I supposed to run this from here? Maybe I'm supposed to go into... I should maybe run it from here and see what happens. They may have like relative paths and things like that. Or it might not just work in... Okay, there's two channels they are using, the Nvidia channel and the PyTorch channel. So Nvidia, so let me just find that. So your suggestion makes sense, right? To install PyTorch, because PyTorch also has CUDA Toolkit, but actually for this paper, they mentioned specifically that there's another CUDA Toolkit that we need to install. So it's actually a separate one from PyTorch itself. Because PyTorch actually will install 11.3 and they need to have 11.1, which is a special library that already has some things for style guns. Actually, it's working here for some reason, right? We've done it. Yeah, I'm not sure how they got it to work. Yeah, let me see how is my... Is it running? It's finished. So it's completed. So let's see, try the next step. So maybe I don't even have to get my environment up and running. But I'll try anyway. It's just, so I guess this is the best they could come up with. And one thing I forgot about is maybe that StyleGAN doesn't deal with glasses very well. And I have glasses, right? So that would be potentially one of the reasons why this didn't work. Well, the guy doesn't have glasses, but I have glasses. Right, yeah. Okay, the toolkit. Okay, let me just see if I can just get separate instructions on how to install this. It's not the same. This is not the same as CUDA toolkit. So PyTorch uses Ninja, that's why they were installing Ninja in Google Colab. And then CUDA toolkit. Oh, wait. Okay, there's a Docker image. I might actually go for Docker. Because with Docker, I know... It's a completely different place now. EG3D. Yeah, correct. So there is no... I mean, the YAML seems correct. It says that there is it's mentioning the Nvidia channel and the channel for PyTorch, but it doesn't seem to be finding the actual CUDA toolkit that they say is special. I'm just going to do a Google search and hopefully I'll find that in... So this is the Nvidia channel. So they have... They don't have 11.1. Maybe they've taken it out. It's too old, maybe. I'm a bit surprised. 11.1. Yeah, they don't have it, which is a bit very strange. Okay, let's see what happened here. So I've run this code. Okay, so the optimization video is already there. I didn't see the... Okay, let's see what's the result. So the video.gif. So this is my image. Looks huge. And then I have the video GIF file. I don't know what that is. Oh, video.gif. Oh, it's a GIF file, like with. I see. It's actually. I understand why it's an animation basically. So I'm going to download that. It seems to be a bit big. I'm actually curious to see what actually created. So. So I couldn't find the CUDA Toolkit 11.1 in the channel, but maybe I didn't look hard enough yet. But it's not. I'm going to. I'm actually quite lucky because I think the collab is actually working, so it has managed to produce something. I can even get a mesh, which is awesome. So I'm going to be able to. Okay, I'm going to connect to Google Drive. Let's see. Asking for a lot. Okay, so I'm downloading the GIF file. It's quite big, and I'm generating a mesh. And it's saving it directly to my Google Drive, which is awesome. So far, I'm actually quite impressed. Whoever worked on this notebook did a really good job, I think. So I want to, to be honest, I want to see what they did differently here, because they didn't seem to install anything with Conda, right? They downloaded EG3D. They downloaded the model weights. They installed Ninja build, which is used by PyTorch, PyTorch. Then installed this library, lpips, trimesh, trimesh. Then this step here was to add the EG3D to the path, the library path. And they picked the CUDA device for the GPU, I guess. And they opened the model. Yeah, so they didn't really have to. I think what they did, they just created a. I think I see what they've done here. They've basically simplified by just creating a pickle file. What they've downloaded. Yeah. Yeah, I don't know. Right, but it's working, which is what matters. Okay, I'll try Nvidia SMI. One second. So I think it should work from here. Nvidia SMI. So I have my GeForce RTX 3070. I'm actually on CUDA version 11.7. I'm surprised. I don't remember upgrading this. Yeah, looks okay. No, I think normally it's much easier to test this with a Docker container, so I don't have to worry about trying to get things to work on a Windows machine, because these projects are not done on a Windows machine. They are done on Linux environments. Yeah, so normally. Yeah, my CUDA works. It's just that it can't find. Look, when I try to run this, it can't find this package in the Conda. Yeah, so it shouldn't be a problem. Okay, so I have my video file now, so I'm going to open it. I'm a bit curious. So this is the result of fitting the face to me. Oh, they have glasses, but they lost it. Okay, so they didn't have a version of me without glasses, with glasses. Okay, this is cool. Right, and you can see, well, if the gun was a bit better to recognize my image, right, then it would have been a bit better. Okay, so let's try the one in Blender. I'm just going to open Blender, and I'll go back to the problem of trying to set up my own environment. Yes, just bear with me. I think the mesh must be quite big because it actually asked me to connect to Google Drive. So I'm just going to download the pickle, sorry, the mesh from my Google Drive. So, EG3D, yeah, it created a folder, and I have my own version in 3D. My lookalike, let's put it that way. It's not exactly me. So this one? Yeah, I just... Yeah, why? I'm not sure if it's... What is this? Not sure if that's what they want me to see. So it must have color. So I'll probably open this in Blender instead of... It's the same file. Okay, so I think I have the right file. So let me open this in Blender. So I need to import a file. So Blender, so import is a PLY. They should have that format somewhere here. Yeah, here. It's this one. And there should be a texture. It doesn't have a texture, I think. So let me go back to the Google Colab. And is this supposed to have any texture? So this 3D export probably not working too well. Okay. So I see this is not completely working, but you know, the fact it can generate let's see. It's promising, right? This kind of research. Yeah, so they've created some code just to create a mesh without colors, right? It's just geometry. So it needs a bit of extra work for fitting the texture as well. Yeah, but yeah, it's quite promising. Right, so let's go back to this setup and see if there is any. So you mentioned the requirements.txt will have the dependencies, right? You're right. Should have a requirements.txt somewhere, right? And this one doesn't seem to have it. Right, so they have, yeah, they don't have requirements.txt, they have environment.yaml. So if I just bump the version of the CUDA toolkit, right, and see if that's the reason why, you know, because from what I could gather, the CUDA toolkit, it's not in the channel anymore, maybe. So let's just try to bump it. 11 point, let's see, 11.2. Right, it seems like you have a lot of experience, Shar. Is it Sharsnik, right? What's your background? Do you have experience in 3D deep learning? Okay, doesn't find this one either. Yeah, I have that file, right? So the file is here. So this is the file, environment.yaml. So I've just changed this CUDA toolkit to 11.2 to see if you can find it. So I'm going to bump it again and see. Oh, really? Cool. About what? About nerf? Did you say nerf? Yeah, neural ray. Oh, that's cool. So let me see. Nerf. Oh yeah, nerf. Okay. Yeah. So what do you think about this paper from Nvidia? Do you think it's a good a leap forward? Okay, it seems like it allows me to go with 11.3. Yeah, it looks yeah, it seems like it produces results, right? The fact you can actually try the source code, right, and actually it's giving you some immediate results, that's quite encouraging. But I guess the way to. Okay, so what's your favorite paper from Nvidia? At least this year. Okay, so I'm not sure if this is going to work because I've just bumped the version of CUDA to 11.3 and it seems like this one works. But then, am I using the right CUDA toolkit or is it the one that, yeah, ASE? What's that? N ASE. Oh, this one. Large-scale reusable adversarial skill embeddings for physically simulated characters. That's cool. Yeah, maybe one day I'll try that. I actually know these are Sanja Fiedler, right? She's probably the she's in quite a few papers I've seen as well, her name. It's probably because she's the lead of the lab in Toronto, right? Wow. Yeah, this looks pretty cool. It's the real thing, right? Wow, okay. I'll definitely check it out at some point. Definitely. So it's still running. Yeah, this is interesting. Yeah, so Nvidia has good research. I've looked at some of their papers and they are quite good. And they are very active. Still installing. Sanja Fiedler not here. Okay. Okay, seems like it takes a bit of time to set up. And we have CUDA Toolkit 11.3.1. But here it was asking for 11.1. Okay, so I think this is probably going to take more time than what I have available here. I might actually do this in a separate live stream or do this offline and just create a video on it. Yeah, thanks for joining me in the live stream. Yeah, I'll definitely follow up this either with another live stream or with the video where I just show you the setup of this in your local environment and you can try this out. You already definitely can try Google Colab and yeah, you're most welcome to join. Don't forget to click the like button if you like this, if you found this live stream useful, and see you again soon. Happy coding.